Welcome to this study of lessons through linear algebra. This lesson will take you through elementary row operations and some things you're supposed to know. Okay. All right. So I have some rules that we are supposed to go through here. The first thing is whatever this operation is. Okay, you can do multiply a row through by non-zero constant, and all these things is about is doing some operations on matrices on rows. All right, so you can multiply a row by any constant that you want. That's a non-zero constant, and it can be a fraction. So you can choose a constant to be maybe 1/2 and multiply through that first row, maybe second row, whatever row you are working on. Okay. And the second thing is you can interchange two rows. So you can choose to, maybe you think that if you bring the first row up on top, it's going to be very, convenient for you to work with. So you can try to do that. You can add and subtract a multiple of one row to another row. So maybe that's basically the last point is what is so important, because mostly that's what we'll be doing. We'll be multiplying one row by a constant and then subtract or add it to another row to get something else. All right, so with all these rules in mind, let's go look at how these things can work. I'm going to find the augmented matrix for the system. So okay, so for system 1, you remember the augmented matrix is the numbers in front of the variables. So you count how many variables do I have? I have x1, x2, x3. I mean, you can look through all of them and look at, okay, I have 3 different variables, but then in the first equation we only have 2 of them happening. So it means in the first equation the coefficient of x1 is 2, the coefficient of x2 in the first equation is 0, so I put 0 there because there's no x2 here, so you can actually add it like plus 0x2, and that makes sense, right? So the next thing is 2 in front of x1, and then you write the value you have here, 1. Okay, so then you go to row 2 and you have or equation 2, you have 3, -1 for x2, 4 for x3, and then we have 7 at the end. You go to row equation 3, I have 6 for x1. Sorry, I gotta be consistent with this. 6 for x1 and 1 for x2, and I have -1 for x3, and then the last one is 0. So this is the augmented matrix you can get out of the first system. Okay, now look at the second system and you ask yourself, I have 1, 2, 3 equations, and in that equation I look for the values or the numbers that are in front of each variable. So in equation 1, I have 1 in front of x1, I have 0 in front of x2, there's no x2 there, so I can put it like that. I have 0 in front of x3, and then the last part is I have 1 at this part. Okay, so you can do same for the other ones. I have 0 for x1, I have 1 for x2, I have 0, and then I'm going to have 2 at the last one. Then I'm going to have 0, 0, and then 1, and then the last one has a 3. So that is the augmented matrix for this system. All right, now let's look at finding the system of equations with a given augmented matrix. So if you come back here, you realize that the last column is always the ones at the end of each equation, and then the ones we have before the last column is the coefficients of the constant or the variables. Okay, so here I have 1, 2, 3 equations, and I have 2 columns in the first, and I have last column here. So it means I have this last as my ending values, or maybe the values I have at the right side of the equation, like these ones. Okay, so sorry, what I'm going to do here is if I look at the first equation, it means the coefficient of x1 is 2 plus 0x2, and the reason I know that this is just x1 and x2 is because I have only 2 columns, so I have only 2 variables I'm dealing with. Okay, if you come back to the previous one, when you have 3 columns, you are dealing with 3 variables, and the same thing happened here. Alright, so I'm going to have 2x1 plus 0x2, which I will not write, is equal to 0. That's the number at the far end of that row, and I go to row 2, I have 3x1 minus 4x2 is equal to 0. The last one is going to be 0x1, so I will not write that, and I have x2 should be equal to 1. Alright, I hope this makes sense. So basically that's how you're going to get this system of equation from this augmented matrix. Okay, on the other hand, I can also do the same thing here. I can have 3x1 plus 0x2. So I'm gonna write just the s3 component should be equal to 5. I have another one, 7x1 plus x2 plus 4x3 is equal to -3, and I'm gonna have -2x2 plus x3 to give me 7. Right, so this is the system that corresponds to the augmented matrix there. Okay, so now let's go to putting these things in practice. Okay, solve for x, y, z in the system below. So this is where you're going to need the elementary row operation. Okay, so I have this. So what I'm going to do is I'm going to transform this into a matrix operation, which I'm going to use a row reduce echelon for, maybe the elementary row operation. Okay, so I have 1 x, then 1 y, and then 2 z, right? And I have the last value to be 9, so I put it there. Then I go to the next equation. I have 2, 4, -3, and I have the last value to be 1. This one I have 3, 6, -5, and I have 0. So what I'm going to do is put these there. Okay, so what I'm going to try to do here is trying to make sure that if I stand on this first leading value in the first row, make sure that all the other entries below it is 0. So that's where the elementary row operation comes in. So what you're going to do is to compare these two values, okay, and look at what you can do to make sure that 1 and 2 are the same. If I have 1 and I have 2, what can I do to either 2 or maybe 1 to make sure that they are the same? It's either I multiply 1 by 2 and then it will be equal to 2, or maybe I have the same one, I keep 1 and I divide 2 by 2, or maybe I multiply 2 by 1/2. So in all cases, it depends on what you want to do. I want to do away with fractions. I don't want to play with fractions, so I'm going to multiply. So we are going to transform this into something. And what we are going to do is that our new row 2 that we should get should be equal to 2 row 1 minus row 2. And what I mean by that is I'm going to multiply this guy by 2 and I'll subtract this guy from it. And that is, the first one is happening on row 1, and that is 2 times row 1 minus row 2, right? Then I compare this same thing and then the last value, because I have to make sure that everything under the 1 is 0. So the same way, I'm going to transform row 3. Our new row 3 should be equal to 3 row 1 minus row 3. And this is going to give us a new augmented matrix, or maybe a new matrix. And that, let me write it down here. Let me put it this here, and then let me write this with a new color. So I'm still going, the only thing that we did not transform was the first row. So I'm going to write everything. Let me just use the same color for everything so that we can go through it fast. If I do that, I'm going to get 0 here, because 2 times 1 will give me 2, and then minus 2, I have 0. Now 2 times 2 is, 2 times this 1 is 2, minus this 4 is going to give me -2, and then 2 times 2 is 4 minus -3, and that's going to give me 7, and 2 times 9 is 18, minus 1 is 17. So what you are doing is you do it for everything you have in the row. Now the new row 3 is also going to be 0, because 3 times 1 minus 3 will give me 0, and I have 3 times 1 minus this guy. 3 times 1 is 3, minus 6 is -3. 3 times 2 is 6, minus -5 is 11, and 3 times 9 is 27, minus 0 is still 27. Right, so now we have this. On the other hand, what you can also do is compare these two values. Okay, after everything, I'll tell you something about this. You can compare this to some people try to make sure that they multiply through by -1 to make sure they do away with the positive, but that depends on whatever you want to do. But on my side, what I'm going to transform this into is make sure that you go to the next row, you look for the leading value, which is -2, and then let me stick to the positive one. So you want to make sure that these two values are positives, right? You can try to multiply the row. So what I'm going to get is my new row 2 should transform into negative row 2. That is negative times the original row 2, and then row 3 should also transform to negative row 3, and that's going to give me a new matrix in this form, or new augmented matrix in this form: 1 2 1 1 2 9 0. I'm going to have 2 here. I'm going to have -7, -17, and I'm going to have 0 3 -11 -27. Now what we're going to do is transform it again. So a new transformation is to make sure that you look for the next leading value in the second row, which is this 2, and make sure that every value beneath that is 0. All right, so you compare 2 and 3, the factor or the constant I'm supposed to multiply to 2 and 3 so that they are the same, or maybe 2 or 3 so that they are the same, is that I have to multiply 2 by 3 and then 3 also by 2. So if I multiply this 3 by 2 and this by 3, they are going to give me the same values, which is 6, right? So I'm going to do that to the new transformation, and that's going to be our new row 3. Row 3 is the one I'm transforming, right? Should be equal to 3 row 2 minus 2 row 3. So it's like you're doing this, your 3 row 2 minus the original 2 times row 3, and this is going to give us this transformation. I'm going to have 1 1 2 9, let me put it here, 0 2. We didn't actually do anything to the other one, and 0, and then this will give me 0 because 3 times 2 is 6 minus 2 times 3, and that is also 6, so I'm going to get 0. Now 3 times -7 is -21, right? So I have -21. Then minus 2 times 11, -11, that is -22, and that's going to give me -21 plus, right, 22. I don't know if that's right, but I think it should be. Yeah. So that's going to give me 1. So I'm going to have 1 here, and then on the other hand, 3 times -17 minus 2 times -27. So 3 times -17 is actually what? -51. So -51 minus 2 times -27, that is -54, I think. Yeah. That gives, yeah, -54, and this is gonna be 3. Yeah, I'm gonna get 3, right? So I have 3 here. So what is this whole final thing is telling us is that we have a system that has been able to reduce to this matrix 1 2 1 1 2 9, and the 0 2 -7 -17, -7 -17, and I have 0 1 0, no, I think 0 here, 1 and 3. So what this is telling us is that you're going to compare this to the equation we had. Previously, if you're supposed to really look at this in terms of metrics, I've not taught metrics, that's what I'm not doing that, but it's supposed to be that this whole equation can be transformed, or can be rewritten. This one can be rewritten as a matrix 1 1 2 2 4 -3 3 6 -5 times x y z. Okay, multiplying x, y, z should be equal to 9, 1, 0. If you've done matrix, you understand this. So what I'm supposed to know here is that this is telling me that we have this matrix, which is for the variable ones, 0, 2, -7, 0, 0, 1, times x1, or maybe x, y, z, should give me the new reduced side of the product, or the ending part, -17, I think. Yeah, -17. Yeah, so I have -17 and I have 3 here, so that's what it means. Okay, or you can also use this little trick, because this is when you understand matrix. A little trick is that you put your variables in place of their position. So you have x in the first position, y in the second position, and z in the second and third position. So look at the last row. Okay, the last row has this thing here and it's equal to 3. So what you're going to do is you're going to take 0x plus 0y plus 1 times z should be equal to 3. And from here, these two guys will give me 0. So I'm going to have z to be 3. All right, so this process is called back substitution, but you know, we don't really care about that. So you look at the second row, row 2 here, and doing so, I'm going to have 0x plus 2y minus 7z should be -17. And from here, this guy will be 0, so I don't care. I have 2y minus 7 into z is 3, and that is -17. So I'm going to have 2y to be equal to -17 plus 21. And I have y to be equal to, 2y to be equal to 4. That's what I'm going to get. So y is equal to 2. Right. So I have y and z. Now from the row 1, what you're going to do is you put their numbers there. So 1x plus 1y plus 2z should be equal to 9. And here I have x should be equal to 9 minus y minus 2z. So what I do is I put their values in there, and then I'm going to have 2 minus 2 into 3, so 9 minus 2 minus 6, which is 1. So I have my x to be 1, y to be 2, and z to be equal to 3. All right, so this is the process you use to solve for your system using elementary row operation, or maybe some people will call it Gaussian elimination. All right, so I will actually tackle that. So this is how you do it. I'll see you in our next lesson.